on to step number 6, which is to assign primary keys to all strong entities. So remember, a strong entity is an entity that does not have total participation in the relationship with any other entity. So the strong entity can exist without any other entity to exist. It has an ID and a value on its own. Okay, so that's the definition of a strong entity, and our task now is to assign primary keys to all strong entities. But first, let's have a look at what I've written here. Prefer surrogate keys. So this is, I wouldn't say controversial, but maybe not everyone agree. It is a quite common strategy, but it's not the only strategy, we could say. Okay, so why? So prefer surrogate keys. I mean, we should not use natural keys, something that has we should not use an existing attribute that has another meaning. For example, we could be tempted to use the person number as the primary key of the person. But my suggestion is never to do that, at least unless we have there is some special case where we have a special very good reason. But the default should always be a surrogate key, that is to invent a key that is used only as, invent an attribute that is used only as the primary key in the database. That attribute could, for example, be called ID. So at least all strong entities will have an extra attribute called ID. Why? Well, first let me meet an argument against this, which is that we waste disk space. That's true, by adding the extra attribute. True. And it might be a significant amount of disk space if we have a very huge table. But normally disk space is not, we are not short on disk space normally. If that is a problem, okay, then we should consider not using a surrogate key maybe. But what I'm saying is that the default should be the surrogate key. And it's not quite very common that we are forced to choose another solution just based on disk usage. Okay, but the advantage of using surrogate key is that we avoid the duplicated meaning. I mean, I feel rather the other way around. Why should we not have a surrogate key? Why should we use person number as primary key for a person? The person number has some other meaning. It is, well, you know what a person number is, kind of identifier of a person. But that's the business model identifier, the real word identifier, not database identifier, and we should not mix those. It only creates problem. There's no point in having the same attribute. There's no point in letting the same attribute have two purposes. That's duplicated usage somehow, which is likely to create problems. A primary key should never change, for example. And what if a person changes person number, which is possible? Okay, then the primary key changes, and that creates problems. Maybe not unsolvable problems, but it creates problems. And why ask for those problems? As a side note, I once was working with an application that had a database maintaining kind of healthcare records, you could say. Or rather test records. The patients left blood samples, for example, and they were tested, and the results were in this database. We had kind of healthcare establishment ID, like in our sample database here. And we used the healthcare establishment ID as a primary key for the table where identifying where the patient had given the blood, for example. And it was not enormous database, but quite big. Okay, and that worked fine for some period, but then all of a sudden the healthcare establishment IDs were changed for the whole organization, and that meant all our primary keys changed, and that created problems. You can easily say. Okay, so that was a real world example. But okay, my point is this: why why use natural keys at all? Why have duplicated meaning of an attribute? Why not have a dedicated database ID? In fact, I would go one step further and say that each entity, at least each strong entity, has in fact 3 attributes. Let me write this. The first, have 3 IDs, I mean 3 primary keys, you could say. First, it has the real word. Let's take me, for example. First, I have the real word ID, which might be my person number. Then I have a business ID. In my case, it's my employment ID or user ID, or whatever it's called. No, it's called employment ID, I think, at KTH, which is not my person number. And then, okay, I don't know the internals of the databases at KTH, but if they think like I do and prefer surrogate keys, then I also have a database ID in their databases, which is the surrogate key. So each entity has, in fact, 3 identities, at least potentially. So this is a suggestion that it's not my, well, it's my own thinking based on my experience, but it's also quite common way of reasoning regarding IDs and primary keys. So I'm not forcing you to follow this suggestion. I mean, you're free to choose what you think. You to do as you like in the project and in your own applications. But this is a strong suggestion, I would say. But okay, but maybe especially the business ID is not required in the project. You're free to omit that. Let's put it in parentheses. But in the real world application, I would definitely strongly consider modeling it like that. We will use surrogate keys in this sample database that we're creating now. Okay, that was a short detour on surrogate and natural keys. So now let's start assigning primary keys, and we look at our model, the conceptual model, and we see that there is the person is a strong entity. It has no total participation. It has 0 at all other ends. And the person can exist without it. I mean, logically, we can have persons in a database, for example, a patient who has not yet visited any doctor. We see that doctor is not a strong entity. There is no doctor without person, because the doctor's personal data is stored as a row in the person table. There is no visit without both doctor, patient, and the healthcare establishment. Okay, we could always discuss that. You never have phone visits or what, but okay, that's up for discussion with the customer. As it looks now, we don't have any visit without. Each visit has both doctor, patient, and healthcare establishment. The visit always, so the visit is not a strong entity. There are no independent visits. And the visit purpose is also not a strong entity. We cannot have like default purposes like fever, whatever. But we only enter visit purposes when in order to describe a particular visit. So visit purpose is not a strong entity. Healthcare establishment is not a strong entity because each healthcare establishment must have an address. So there must be an address for the healthcare establishment, but the address seems to be a strong entity because we have written that we can have addresses without person and we can have addresses without healthcare establishments. But now I would start to think a bit here. Is that really are we really correct? Is this way of modeling it? Do we want addresses? Do we want rows in the address table that do not correspond to either a person or a healthcare establishment? No, we don't. Then we just have empty addresses. I mean, dangling addresses. Why should we have that? That seems a bit strange. The zeros here come from the fact that the address is associated to either a person or an healthcare establishment, but not to both. So it will be, or at least not necessarily to both. I don't know if a person can live at the healthcare establishment. Okay, never mind. But it's not really correct modeling this. The healthcare establishment's address should always be associated with the healthcare establishment. So it's a bit weird, this 0 here. So I think, okay, we could model it as is done here, but I think it will only create problems. Also, we will have to do all the joins every time that we want the address of a person of an healthcare establishment. So I'm thinking that we should do some slight denormalization and move these attributes to both person and healthcare establishment and delete the address entity. The downside of this is, of course, that we have these duplicated attributes. So if we want to change the format of how an address is stored in the database, then we have to change that in 2 places now with this change. With this update to our model, we have to change it both in the person and the healthcare establishment. But I think I'm willing to take that risk. A reasonable assumption that we won't update the way an address is stored, at least not often. It will be extremely rare. An address has a street sequence. Okay, we can reason backwards and forwards about this for some time, but I think let's decide that we have to delete the address entity in order to avoid the problem with dangling addresses and knowing if an address is associated with a person or an healthcare establishment. We would probably have to have 2 foreign keys in the address table, one for person and one for healthcare establishment, and one of those would always be null if we kept the address entity. We could do like that, but I think it seems more reasonable to move the street, sit, and city to both person and healthcare establishment. That, one could argue, is some kind of denormalization. We could claim that, for example, that SIP and city depend on street, and the street will depend on the primary key of the entities where it is located. So that breaks the third normal form, we could claim. But okay, I mean, we should not go to extreme lengths of normalization, in my opinion. We should allow this kind of very slight denormalization if it improves the design in some other sense. In this case, simplifying the maintenance of addresses. Right, so we decide to do that. Okay, so the address entity will be deleted, and then also the healthcare establishment will be a strong entity. It has no total participation, it can exist without visits, and it has no relation to any other table. It can exist independently of other entities. So we have 2 strong entities to which we should assign primary keys, and we have decided to use surrogate keys. And we should also delete the address entity. So let's do this. So first let's delete the address entity. There, now we have deleted the address table and moved the attributes to person and healthcare establishment. Great. So then the next thing was to assign primary keys. And we create the primary key for the person. We do as suggested and call it just ID. We could also call it person ID, to be clear. Okay, but let's just keep it as ID now. And then for the data type, so there's a problem for the type. Let me explain first. I'll just write int here. which is in fact the type that the primary key will have. But there is a Postgres specific data type that would be nice to use, which is serial. It shall be serial. And serial is an int which will be stored as an int in the table, but it is a shortcut, we could say, for writing a sequence, to make sure Postgres create a sequence. If we assign, as we will, the type serial to the ID in Postgres, then we don't have to create that ID ourselves. When we insert the person, we just insert all the other attributes, and Postgres will create an auto-incremented ID, 1, 2, 3, and so on. We'll not guarantee that all numbers will be used. There might be gaps, but each primary key will be unique. So that's a good way of letting Postgres handle the ID generation, and we are sure the ID will always be unique. Okay, and we do the same for healthcare establishment. ID like that, and also this should be serial. There. Okay, so now we have assigned primary keys to the strong entities. There were 2 strong entities, and that means we are done with step number 6. Okay, so on to the next step, which has some sub-steps. So this step concerns all one-to-one and one-to-many relations. So here we'll start creating relations. We will not yet consider many-to-many relations. Those will come in a later step. Okay, so for each of the relations, we create the relation, and we create a foreign key in the weak end. And as the foreign key, we use the primary key of the strong end. And then we have to assign a primary key to the weak end, and if the entity at the weak end has a meaning on its own without the entity on the strong end, we use a surrogate key. For example, a doctor is a meaningful entity that has a meaning on its own, so we will give the doctor a surrogate key. Whereas, for example, the visit purpose has no real meaning without visit, so we will use the foreign key of visit purpose, which is the primary key of the visit, as primary key in visit purpose. Okay, but you will see this when we come to those relations. Finally, we should also consider foreign key constraints. A few more words about foreign key constraints when we get to the point of assigning foreign key constraints for the first time. Okay, so we move back and start with point A, create the relation. So we will do all these 4 steps for each relation, and then all 4 for the next relation, and so on. So first, let's look at the relations. So the existing relations that we are to consider is this one-to-one relation between doctor and person, and then there are some one-to-many relations here. The address entity has been deleted, and so also these relations have been deleted. Right, but let's start with the one-to-one relation between doctor and person. So person is a strong entity and doctor is a weak entity, and then we'll handle this relation and assign foreign keys and primary keys to the weak entity, the weak part, the doctor. Okay, we do that. So I have reordered the entities a bit to make more space. So we start by assigning by creating the relation. So this was the first step, right, to create the relation. And the relation should be 1 at the person end and 0 or 1 at the doctor end. So 1 at the person end, and it should be not 0 or many, but 0 or 1 at the doctor end, like this. Okay, And now we can see that, okay, so this was create the relation, first step. Next step, create the foreign key. And we can see that Asta created the foreign key for us. So it's here the ID of the person ID became the foreign key. And the primary key of the person table became the foreign key in the doctor table, which is fine. But let's rename it to person ID, which is good practice to highlight that it's we prefix. So the name of the foreign key is the name of the primary key prefixed with the name of the table containing the primary key. So ID here is ID there, and person here is that person. Okay, right. So that was the foreign key, and it should be, of course, not null since, okay, I can draw. It should be not null since we have one, it's the other end is mandatory. The type is int, which is the type of the primary key. Also, when we later specify serial as the type of the primary key, then remember serial is just a shortcut to make it a sequence that is managed by the Postgres, but the actual type of the column will be int. So those have the same type, the foreign key and the primary key. Okay, that's fine. Now we have assigned the foreign key. Next, the primary key of the weekend. Use a surrogate primary key if we should use a surrogate primary key if the weekend has meaning without the strong end. And in fact, okay, this is up. It's not. I mean, you have to evaluate whether you think the doctor entity is meaningful on its own. I think it's quite clear that there is such an entity in this business as a doctor. It has some meaning. So that means we do not use this as primary key, like that. We create the primary key, which then, as all primary keys, is called ID. This ID thing is the primary key, right? And its type will be int, like that. Okay. Of course, the primary key is not null. So it should also be serial. This note thing here is becoming a bit. I think I remove these lines and just make a general note. All primary keys which are specified as int shall be serial. Okay. Like that. So we don't have to draw lines all over. Okay, that was the primary key of the doctor table. Right, I think that's that, yes. And then consider foreign key constraints. So foreign key constraint is to specify what shall happen with the row containing the foreign key when the row in the other table containing the primary key is either updated or deleted. And update, we are lucky since we use surrogate primary keys. The primary key should really never be updated. And if it is for some extremely strange reason, we can stick with the default, which means not to allow updates of the primary key, but to raise an error in that case. Okay, so we don't have to bother about updates. But for deletes, there are 4 alternatives. One is to prohibit, we could say. Prohibit deletion of a row with the primary key while there exists a row with a foreign key related to that primary key row, which actually is called no action. And this is the default. Then there's also the alternative to allow, we could call it. is called set null, which means if the primary row with the primary key is deleted, the foreign key is set to null. And then there is the third alternative, delete, which is called cascade. So that means that if the row with the primary key is deleted, the row with the foreign key is also deleted. There are some more options with subtle differences, but these are the ones I will consider here, that those are enough for us now. So what shall happen if someone tries to delete a person that specifies an existing doctor? The default is fine, prohibit. I mean, we leave the default. We do not have to specify any foreign key constraint. It's prohibited. An error will be raised if someone tries to delete the person related to this doctor. Because if the doctor exists, then the person data related to this doctor must also exist. Right? So then we're done with our first relation. So then we move to the next relation. So we can say that now we have handled the doctor table, the person table, and the healthcare establishment table, and we have assigned primary keys to them. Okay, person and healthcare establishment were done before. Now we are done with doctor, and we have fixed this relation. Then we can see that we do not have the option of choosing of handling this relation. That's not possible because it involves both visit and visit purpose, and none of those have yet a primary key. They have not been assigned yet. So we have to first manage visit. This is our next focus, and to do that we have to handle these three relations. So let's start with the first one, between doctor and visit, which is 1 at the doctor end and 0 to many at the visit end. So let's create that one. Something like that. 1 at doctor end and 0 to many at visit end. Yes. And foreign key was assigned by Asta. So we did create the relation, and we are considering the foreign key. And first of all, first we can see that Asta made this the foreign key. That's fine. It's not null. That's fine. It's mandatory at the other end. And the type is int. Fine. The same as the primary key. So next thing is to change the name. It should not be ID, but doctor ID. And also next, okay, that was this, and then whether we should use this as primary key or not. Okay, I would say that this is, of course, not, I mean, subjective. Do you think that the visit is important enough to have identity on its own, or is it not? Shall it only have the identity of the things that are related to it? I think the visit should have an identity of its own, so I will not keep this primary key. If we can understand that there will be more relations from person and healthcare establishment, and so we will have 3 more foreign keys. So if we want not to create a surrogate primary key, then the primary key will be the combination of the foreign keys of all 3 related tables, doctor, person, and healthcare establishment. But now let's create a surrogate key. So let's not use this one, but instead create a new, which is called ID, has the type int, kind of like that. Yes, okay, so we are done with this relation. Next, let's consider, we did create the primary key, right? We did also, that step was done, but we did not consider foreign key constraints. So what about this? Remember that the alternatives were prohibit, allow, and delete. So the default was prohibit, and that's fine again, I think. It should not be allowed to delete a doctor of a visit, because then we lose the history of that visit. It will not be possible to see who created this visit, which doctor managed this visit, I mean. Okay, so we leave it like this, right? And then we, go back and take the next relation. And now I will leave it as an exercise to do these two relations. So pause the video and add those two relations. Okay, so let's have a look at those relations. I have added them here and here. And as you can see, they are completely identical to the one between doctor and visit. Exactly the same reasoning applies to everything. So they are in all senses identical. And now let's move on to the last thing here, the visit purpose table and the relation between visit purpose and visit. So first we create the relation, and we can see that it has one at visit and one to many at the visit purpose. So let's create that relation. We should have one to many at the visit purpose. Let's hide that. Okay. It created the foreign key but called it ID. It would be better to call it visit ID according to our practice. Visit ID, like that. Okay. Its type is int, which is fine, the same as the primary key, and it's not null because the other end is mandatory, right? Yes, so that was create the relation. And we have also assigned the foreign key. Yes, and regarding the primary key at the weekend, I think this is a situation where we should not use a surrogate key, because the visit purpose is not something that exists on its own. It's some feature of a property of a visit. So we do not assign a foreign key, a surrogate key here, but instead use the foreign key as the primary key, which is exactly what Asta has suggested. So the foreign key here is now the primary key, as can be seen also here, by the fact that it's in the upper compartment. What about foreign key constraints? So here, I think we should not prohibit if the default is not okay. If the visit is deleted, also its purpose should be deleted. So here we do not use the default, but instead should use delete, which is called cascade. So we cannot specify foreign key constraints in Asta, but instead we have to create a note on delete cascade. I'm writing that in uppercase letters because this is what the SQL statement looks like. So that was the foreign key constraint, and now we are in fact done with all one-to-one and many-to-one relations. So that means step number 7 is completed.